Our Sun, a seemingly constant star, has a dynamic history. It experiences moods, some far more violent than others. Recently, scientists uncovered evidence of a truly dramatic event. A massive solar storm struck our Earth long, long ago. This incredible cosmic blast occurred about 14,300 years in the past. Our planet was a vastly different place back then. Humans were living in the Stone Age, quite unaware. They could not have known what invisible force hit them from space. This was not just an ordinary solar storm, it was a cosmic behemoth, a true superstorm of immense proportions. Imagine our Sun, in a moment of fury, unleashing a colossal burst of energy. This torrent of particles and radiation traveled across millions of miles of space. It then slammed directly into our planet's protective atmosphere. Countless high-energy particles rained down upon the Earth's surface. This event was far more powerful than the typical solar flares we observe today. We are still working to grasp its full, immense scale. So how did we unearth this ancient, invisible catastrophe so many millennia later? The dedicated scientists, a team led by Professor Edouard Bard, made this groundbreaking discovery. They were meticulously studying very old, fossilized trees found in southern France. These were not just any ordinary trees, they were ancient Scots pines. These remarkable trees had been naturally preserved for thousands upon thousands of years. Their dense wood held the chemical secrets from a distant, forgotten past. The team's amazing discovery was announced to the world in the year 2023. This significant discovery holds incredible importance for all of us living today. It reveals startling new information about the Sun's most extreme capabilities. The ancient storm was a truly gigantic radiation event, unlike most we knew. It was perhaps the single biggest surge of cosmic rays we've ever found evidence for. This crucial finding helps us understand our own star much better. It also forces us to confront our own profound vulnerability as a species. Our star, the giver of life, can also be a source of immense danger. Trees are like living history books, patiently recording time. Each year, a tree grows a new ring around its trunk. These rings tell a story of the conditions it experienced. They show rainy years, dry years, and even forest fires. For scientists, these rings are invaluable natural archives. They hold clues about Earth's past environment. They are nature's own data storage devices, waiting to be read. We just need to learn their special language. One special clue these tree rings hold relates to carbon-14. Carbon-14 is a rare, radioactive type of carbon atom. It forms high up in Earth's atmosphere. This happens when powerful cosmic rays, including those from the Sun, strike nitrogen atoms. The newly formed carbon-14 then spreads throughout the atmosphere. It eventually gets absorbed by all living things, including trees. This happens during the process of photosynthesis, when plants breathe in air and capture carbon. Scientists are like detectives, carefully examining these tree rings. They can measure the amount of carbon-14 in each individual ring. When they find a sudden, sharp increase in carbon-14 levels, it's a big clue. This spike often indicates that Earth was bombarded by intense cosmic radiation. Such a bombardment could come from a massive solar storm. The 14,300-year-old event left just such an unmistakable signature. It was a dramatic surge in the carbon-14 record. The ancient Scots pine trees from France were the key witnesses. Their incredibly old wood perfectly preserved this carbon-14 signature. It was like a snapshot of that specific year, 14,300 years ago. The trees absorbed the extra carbon-14 created by the solar superstorm. This radioactive carbon became locked within their growth rings for millennia. Thanks to these silent wooden sentinels, we now know about this ancient solar fury. They have given us a window into a violent cosmic past. The 14,300-year-old storm is not the only one of its kind. Scientists have found evidence of other similar powerful solar events. These are often called Miyake events. They are named after the brilliant Japanese scientist Fusa Miyake. She was the first to discover such a rapid carbon-14 spike. Her pioneering work looked at Japanese cedar trees. She found a significant event that occurred in the year 774 CE. This groundbreaking research opened an entirely new field of study. When we compare the ancient 14,300-year-old event to others, its power is astounding. The carbon-14 spike it produced was enormous. It was roughly twice as powerful as the 774 CE Miyake event. That 774 CE event was already considered very large by our standards. This new discovery suggests the Sun can produce storms of even greater magnitude. We are learning that past solar activity could be far more extreme. These events challenge our previous understanding of solar physics profoundly. We know of other, less intense, but still significant solar storms. One famous example is the Carrington event of 1859. That storm was powerful enough to cause telegraph systems to spark and even catch fire. It created brilliant auroras visible even in the Caribbean islands. But a Miyake event, like the one from 774 CE, would be much stronger. And the 14,300-year-old storm was even stronger than that. It was likely 10 times or possibly even more powerful than the Carrington event. These colossal Miyake events thankfully seem to be quite rare. Scientists estimate they might occur roughly every 400 to 2,400 years. However, we have only identified a handful of them so far in the historical record. The 14,300-year-old event is the oldest and most powerful found to date. Understanding their true frequency and the range of their intensity is a vital task. Each new discovery adds another crucial piece to this cosmic puzzle. It helps us gauge the potential risks from our own star. Now let us consider a chilling thought experiment. What if a solar storm of that ancient magnitude struck Earth today? Our modern world is vastly different from the Stone Age. We are now a civilization utterly dependent on technology. Our ancestors 14,300 years ago had no electrical grids or satellites. They would have seen amazing auroras, but their daily lives would largely continue. For us, the consequences would be catastrophically different and far-reaching. We live in a delicate, interconnected electronic web. A superstorm today could cripple our technological infrastructure. Powerful geomagnetic currents induced by the storm could surge through power grids. This could cause widespread blackouts lasting weeks or even months for some regions. Our satellites, essential for communication, navigation, and weather forecasting, could be damaged or destroyed. GPS systems would likely fail, impacting transport and logistics. The internet, the backbone of modern commerce and information, could suffer severe disruptions. Our ability to communicate globally would be massively impaired. The economic fallout from such an event would be staggering. Trillions of dollars in damages could occur worldwide. Imagine the loss of productivity, the chaos in financial markets. Supply chains that we rely on for food and goods would break down. Transportation systems would grind to a halt without GPS and reliable power. Restoring our complex, interconnected systems would be a monumental and costly task. The societal impact would be equally profound, leading to widespread uncertainty and hardship. We are more vulnerable than we often realize. This is why studying these ancient solar storms is so critically important. It's not merely an academic exercise in history, it is about understanding the very real risks we face from our sun. By learning about the frequency and intensity of past superstorms, we can better prepare. We can work to build more resilient infrastructure and smarter grids. We can develop more accurate early warning systems for space weather. Ultimately, understanding these cosmic threats helps us protect our future. It helps us safeguard our fragile, technologically advanced civilization.